welcome to Chemistry 1001, Thermodynamics. We're talking a little bit about endergonic and exergonic processes. So an endergonic process is a bit like an endothermic process. Endergonic, endothermic. Endergonic process is one where delta G is bigger than 0. Endothermic process is one where delta H is bigger than 0. What does this word, by the way, it is not spontaneous. It is not spontaneous. This is an error. Delta S bigger than 0 is spontaneous. Delta G bigger than 0 is not spontaneous. It's exactly the opposite. Now, endergonic has to do with work. So endergonic in Greek means work consuming. So here's an endergonic reaction. We have reactants and they go towards products, and there's a raising of the reactants to the products, so that means delta G is positive, goes from a lower number to a bigger number. We get an increase in our bank account, so that means this is an endergonic process and energy is required, work is required to make those products. The alternative is an exergonic process. Note, like exothermic. Exergonic process is one where delta G is less than 0. Exothermic process is delta G less than 0, i.e. this is spontaneous. This is spontaneous. The previous one was not spontaneous, typographic error. This is work producing. Okay. Here's an example of an exergonic process. We have a heavy weight here and a light weight here connected together. The two systems are coupled together. When the systems are coupled together, work from this system in the form of a heavy weight can be transferred by some means. We don't really know how in general, but in this case it's the string, and the string will pull the light weight up. So by coupling together two systems, we can force one system to do work on the other system. In other words, the heavy weight spontaneously goes down. Delta G less than 0 means it's a spontaneous process, and this means the weight goes down. But another way to think about it is this weight is doing work on the system and pulling the lighter weight up. So you start to see why delta G is a little bit more useful than entropy, because it involves energies. But you must remember that the key idea has nothing to do with energy, it has actually to do with energy. Endergonic and exergonic has no relationship to exothermic or endothermic. Well, it does, but there are 4 possibilities, as we saw before. Endergonic processes can be made spontaneous by coupling with energy supplied from exergonic processes. So the light weight going upwards, that's an endergonic process. It's not spontaneous, but if we couple it together with this exergonic process, it will happen spontaneously. The world is going to run out of